बस यही से। अच्छा, तो हमने किया था शेप्स, और शेप्स में हमने वो सारे एंगल्स पढ़े थे। मॉलिक्यूल की शेप पढ़ी थी। जस्ट वन सेकंड, मैं बोल दूं यहाँ पे। अच्छा, दो बॉन्ड्स होंगे, दो लीनियर होगा 180 डिग्रीज, ठीक है। दिल बी एज फार अवे थ्री बॉन्ड्स दैट्स गोइंग टू बी फैन शेप ट्रायंगुलर planar, three pairs of bonds. Two bonded pairs plus one lone pair, so that will be uh, kind of like a fan with one side missing, ठीक है। Four bonded pairs, तो वो tetrahedral था, जिसकी different versions थी। Three bonded pairs plus one lone pair, that was pyramidal. If you had two bonded pairs plus two lone pairs, that was also non-linear. Five bonded pairs was trigonal bipyramidal, ठीक है। Fan in the middle with one bond on top, one at the bottom. And then you had six, यानी सारे एक्सिस के ऊपर, एक्स वाई जी एक्सिस के ऊपर you'll have six. There were two other versions of six, which was one lone pair and five bonds, or two lone pairs and four bonds. तो कल हमने स्टार्ट किया था, we started with intermolecular forces, ठीक है। We did past paper questions. Intermolecular forces में I told you that when you have a molecule, a covalent molecule, one molecule attracts another molecule, ठीक है, and there's weak attractive forces between them. And usually they are weak. Usually they are very weak. The molecules are freely moving around. They've got low melting and boiling points. लेकिन उनके बीच में भी फर्क है, ठीक है, which is that water will have intermolecular forces which is going to be stronger compared to carbon dioxide. तो कल हमने डिस्कस किया था कि there are three types of intermolecular forces. Like, how do molecules attract each other? So there are three ways. One is a permanent dipole interaction. The other one is hydrogen bonds, which is relatively the strongest. And then you've got van der Waals forces, which are known as instantaneous dipole, induced dipoles, or dispersion forces. ठीक है। एक इसका ना एक और नाम भी है, पता नहीं, मुझे याद नहीं आ रहा। लेकिन anyways, you just call it van der Waals forces or instantaneous dipole, induced dipole. So we started off with the first one, which was इसी को highlight कर लें। अच्छा, this one was permanent dipole interaction. तो इस फोर्स में, अच्छा, what we discussed yesterday was that when you have a molecule, so the electrons are not equally distributed. Why? Because firstly, when you have a covalent molecule, when you have a smaller difference in electronegativity, like HNCl, so the electrons are kind of pulled equally between the two atoms. So the electrons are kind of shared in the middle. Uh, but Cl has a higher electronegativity, which means it has a higher tendency to actually gain electrons, right? So Cl has a slightly higher tendency to gain electrons, which is why these electrons will be very slightly closer to Cl. तो ये वाला जो इलेक्ट्रॉन होगा ना मिडिल में, it's not going to be exactly in the middle. It's going to be slightly closer to Cl, both of them, and that leads to a very slight negative charge over here and a very slight positive charge over here. ठीक है, that's known as delta positive, delta negative, or partial negative, partial positive. Unlike ionic compounds में तो electrons पूरे उठ के उधर आ जाते हैं, ठीक है। So in this case, the electrons just very slightly go towards one atom. And that results in the creation of a dipole. So if there's a difference in electronegativity between atoms in a bond, electrons are unequally shared, resulting in slight negative, slight positive charges. अब दूसरा molecule होगा, that will also have a dipole. So one dipole is going to attract the other dipole. So that's known as a permanent dipole attraction. The positive end of one molecule is going to attract the negative end of the other molecule. So that is why it's called. This one is called a permanent dipole interaction. ठीक है। तो permanent dipole, permanent dipole, और ये मैंने बताया था कि ये permanent ही होगा, ठीक है, it's always going to be there. अच्छा, attraction और interaction, clear है? अहमद, राफिक, clear है?
जी सर.
Yes, sir.
So you'll always have a dipole, right? So in molecules with difference in electronegativity, so there has to be a difference in electronegativity. So there are lots of molecules, but shape also matters in the creation of a dipole. Okay, it really does matter. Shape, the shape of molecule will affect the dipole that's created. अब इसमें होता है, so how does it do that? So when you have a molecule, just if I have a molecule of, let's say, what's a molecule? Let's say we've got phosphorus with fluorines, PF3. Okay, so that's so the shape of the molecule is actually tetrahedral. Okay, so it's like a pyramid, और वो pyramid में ना there are 3 seals that are attached to it. तो यहाँ पे fluorines कर लेते हैं. So there's one fluorine, there's another fluorine, and there's a third fluorine, and there's a lone pair on top. Okay, which is why it's pyramidal. So it's like a fan, जिसके तीनों blades जो है ना fan, they've been bent downwards, and they have an angle of 10. So they have an angle of 107. अच्छा, ये आपके पास था PF3 है. Now in this case, fluorine is more electronegative. ठीक है, वो Pauling scale का I'll put a chart and see which one is more electronegative. So you're Pauling electronegativity values, right? अच्छा, ये नहीं इसमें. अच्छा, fluorine and phosphorus. This table has electronegativity values. अच्छा, fluorine and phosphorus, which is अच्छा, phosphorus is over here 2.2. वो 4. नहीं, वो 4.1 है. खैर इस केस में तो डिफरेंस कुछ ज्यादा ही हो जाता है. ठीक है, रिमेंबर it has to be less than 1.7. PF3, is it covalent? It's या तो ये वैल्यूज ठीक नहीं है. Just one second, let me remember. 1.7 से ज्यादा हो then it's ionic. So ठीक है, इसमें मैं डायपोल्स को एक्सप्लेन करता हूँ. Although difference in electronegativity is high, लेकिन what happens is the dipoles kind of cancel out, but not completely. One fluorine is trying to pull electrons over here. The other fluorine is trying to pull electrons to the other side. And the third one is trying to pull these electrons over here in the bond, to beach bond. So the third one is trying to pull those electrons. और काफी strongly pull कर रहा है. ठीक है, so वो गूल किया था, it turned out to be a colorless gas. So that kind of indicated कि वैसे तो इसके dipoles काफी strong होने चाहिए थे. strong क्यों होने चाहिए थे कि the difference in electronegativity was very high. It should have been ionic even. It's because one fluorine. So why do you think it's not actually ionic? Well, if 4.193 or 2.253. Remember, if the difference in electronegativity is greater than 1.7, the compound is very likely to be ionic. ठीक है? तो लेकिन यहाँ पे अगर PF3 को देखो ना, तो what we read is that it's just a gas. That means it doesn't really have a charge as well. तो इधर मुझे थोड़ा सा explain करो कि can anyone tell me why is fluorine not able to gain those electrons? Anyone, any idea?
Sir, the fluorine from one side is going to be cancelling out the effect of fluorine on the other side.
Yeah, exactly. So what is happening is that partially, and remember partially, if one fluorine is trying to pull electron to one side, the other fluorine is trying to pull the electron to the other side. So both fluorines, ठीक है, it's like कि अगर आप बीच में हो ना electrons लेके बैठे हो, एक आपके electrons को उधर pull कर रहा है, the other one is trying to pull the electrons to the other side. So their effect kind of gets cancelled out. Their force of attraction kind of gets cancelled out. But in this case, it doesn't really get cancelled out completely because the shape of the molecule is such कि वो थोड़ा बहुत नीचे की तरफ pull कर रहे हैं. So it kind of physics में इसमें थोड़ा सा vectors वगैरह आ जाएगा, लेकिन you just have to generally guess. So what happens is that fluorine, the attraction of fluorine kind of gets cancelled out. लेकिन completely cancel out नहीं होती because the shape of the molecule is not really symmetric. ये ऊपर वाला थोड़ा सा हल्का सा positive हो जाएगा, electrons अभी भी थोड़े से ना they'll be slightly closer to fluorine, but the effect will not get cancelled out completely. The effect will get cancelled out completely if you have a molecule and it's symmetric. ठीक है, जिस तरह if I have a molecule of AlCl3 or even AlF3, so in that case the forces of attraction, all fluorines being highly electronegative will try to pull electrons. इसको बल्कि Cl होना चाहिए था, just 1 second. अच्छा, so all the Cls will be trying to pull electrons. ये वाला इधर pull कर रहा है. But in this case, because the molecule is symmetric, ठीक है, उसमें ऐसा सोचो, imagine करो कि the three fluorines are kind of pointing downwards. I mean, they're pointing. It's like a fan, but it's the blades of the fans are pointing downwards. So the fluorines are kind of pulling electrons. वो नीचे की तरफ pull कर रहे हैं. So the effect kind of laterally gets cancelled out. जैसा vector diagram के ना दो vectors होते हैं. लेकिन there's some effect, there's some net effect, which is that the electrons will kind of get pulled downwards. यहाँ पे what is happening is it's like a fan, it's like a flat planar molecule, a trigonal planar geometry. So यहाँ पे one seal is pulling electrons over here, one over here, one over here. The effect gets cancelled out completely. तो यहाँ पे इधर आप लिखोगे there's not going to be any permanent dipoles, and the permanent dipoles will cancel out. As similarly, I'll do another example where the molecule will have symmetry. ठीक है, अगर वो symmetrically electrons को pull करे, और इसमें वही imagine करो कि let's say बीच में ना you have a chair and there's one person pulling over here, one person pulling over here, one person pulling over here. Where will the chair go? The chair will stay right in the middle. The electrons will remain right in the middle. ठीक है, they won't get attracted to one side because the effects of all three are cancelling out. अब्दुल्ला, क्या question है?
सर जैसा आप कह रहे हैं कि PF3 will be also cancelled but laterally so I had a what does that mean? Is it cancelling out or not?
नहीं,
PF3
completely cancel out नहीं हो रहा, क्योंकि इधर तो completely cancel out हो रहा है. इधर इस तरह सोचो कि ये एक बंदा खड़ा हुआ है, एक फ्लोरीन उसको इधर नीचे की तरफ खींच रहा है, एक इधर खींच रहा है, एक इधर खींच रहा है, तीनों को. ठीक है, तो बंदा किधर जाएगा? थोड़ा बहुत नीचे की तरफ ही जाएगा ना. उसके जो इलेक्ट्रॉन्स होंगे वो थोड़ा बहुत नीचे की तरफ जाएंगे. Is that idea clear?
Yeah.
कि मतलब वो टॉप फ्लोरीन से ना 3 लोग लटके हुए हैं, ठीक है, वो उसको खींच से नीचे की तरफ इलेक्ट्रॉन्स को। तो हाँ, साइडवेज वाला इफेक्ट कैंसिल आउट हो जाता है। आई मीन दिस फ्लोरीन इज ट्राइंग टू पुल towards the right, this flow is trying to pull towards the left. उसका जो right और left वाला component है वो that will kind of get cancelled out. तो ये CO2 में देख लेते हैं, ठीक है। अब ये linear है, it's just two pairs of bonds. So it's a completely linear shape. अब मुझे बताओ कि the geometry is symmetric. So will there be a dipole or not? Oxygen is more electronegative. When oxygen wants the electrons towards itself. But one oxygen is trying to pull electrons to the right, the other one is trying to pull electrons to the left. So क्या होगा? What will be the effect? It will get cancelled out. There will be no dipoles. Dipoles होने चाहिए थे, but you won't have dipoles. Dipoles cancel out. Is that clear?
सर तो पहले एग्जांपल में हम एरो डाउनवर्ड्स बनाएंगे और ओवरऑल डेल्टा नेगेटिव होगा वो।
हाँ, लेकिन थोड़ा बहुत नेगेटिव होगा। जितना होना चाहिए था उतना नहीं होगा, क्योंकि उसका जो वेक्टर्स का ना राइट और लेफ्ट वाला कंपोनेंट है ना, इट्स लाइक दिस। थिंक ऑफ इट दिस वे कि अगर मैं इसको साइड व्यू देखूं ना, एक फ्लोरीन को हटा दूं, लेट्स थिंक ऑफ इट एज, बल्कि इधर ही कर लेते हैं, लेट्स थिंक of a two-dimensional molecule. Well, three-dimensional, so that's kind of confusing. Let's think of a two-dimensional molecule, like किसका lone pair? Let's talk about sulfur dioxide. तो वो lone pairs की वजह से ना the double bonds they point downwards, 120-degree angle. मतलब वो fan shaped ही है with one side missing, right? अब इस पे क्या होगा? Vectors किस तरह के होंगे? It's going to be कि one of them wants the electrons to be pulled, मतलब इस साइड पे खींच रहा है, the other one is trying to pull electrons over here, right? तो उसका जो लेफ्ट और राइट कंपोनेंट है ना वेक्टर, अगर मैं वेक्टर हैज टू कंपोनेंट्स, नॉट रियली श्योर इफ आइडिया हो गई कि एक वेक्टर का दो कंपोनेंट्स होते हैं। तो देयर इज वन कंपोनेंट ओवर हियर एंड देयर इज द अनदर कंपोनेंट व्हिच इज पुलिंग इट डाउनवर्ड्स। इज दैट आइडिया क्लियर?
जी सर।
और उस वेक्टर का भी ना दो कंपोनेंट्स होंगे, इट्स वन पुलिंग ओवर हियर एंड द अदर वन इज ट्राइंग टू पुल इट डाउनवर्ड्स, ठीक है। तो वो जो राइट और लेफ्ट वाले कंपोनेंट है ना, दे विल ऑब्वियसली गेट कैंसल आउट। तो ओवरऑल इफेक्ट क्या होगा? द इलेक्ट्रॉन्स विल बी काइंड ऑफ पुल्ड डाउनवर्ड्स, राइट? तो जितना होना चाहिए था डायपोल उतना नहीं होगा, बिकॉज देयर इज सम कैंसलिंग इफेक्ट एज वेल, बट द ओवरऑल इफेक्ट वुड बी कि द इलेक्ट्रॉन्स आर काइंड ऑफ गोइंग टू बी पुल्ड टुवर्ड्स द बॉटम साइड ऑफ द मॉलिक्यूल, और वो जो ऊपर वाली साइड होगी ना, दैट विल बी स्लाइटली बिकमिंग इलेक्ट्रॉन डेफिशिएंट। इज दिस क्लियर?
जी सर। सर तो वो जो वाई कंपोनेंट्स थे वो ऐड हो जाते हैं आखिर।
हाँ, ठीक है।
ओके सर।
तो आपने इतना डिटेल भी सोचना, यू डोंट हैव टू थिंक ऑफ इट इन सो मच डिटेल के मुझे वैसे बता दो टेट्राहेड्रल स्ट्रक्चर है। इफ आई हैव carbon with and it's tetrahedral, because I've got a carbon atom and as a carbon, और इसके साथ 4 Cls attached है। अच्छा, so I've got a carbon with 4 Cls. Will the dipole get cancelled out or not?
जी सर।
इसमें भी ना the 4 Cls are kind of pulling electrons in a three-dimensional way in 4 different directions, ठीक है। Remember Cl is the electronegative part. It's the electronegative atom. एक आपकी तरफ pull कर रहा है, and it's a completely symmetric molecule. It's 109 point, all bond angles are 109.5. Like this is a three-dimensional shape. This is a three-dimensional shape. लेकिन उनकी जो forces होंगी ना, they're going to get cancelled out. So the electrons will kind of remain distributed evenly. ये नहीं होगा कि वो एक साइड पे चले जाएंगे, ठीक है। All forces of attraction will kind of get cancelled out. तो इसके अंदर भी the dipole is going to get cancelled out. अच्छा, what about SF6? उसके अंदर डायपोल कैंसिल आउट होगा? if I have an SF6 molecule, so what is going to happen is,
जी sir.
one bond is to the top, the other one is on the bottom. You've got one on the right side, one on the left side. एक उसके back side पे जा रहा है, and one of them is coming towards you. So all fluorines and their attractive forces are going to get cancelled out. So no dipole. तो आइडिया क्लियर है कि when you have a symmetric shape, जैसा ये है symmetry है इसमें ना, ठीक है, center से symmetry है, like if you stand on the center it looks exactly the same, if you stand over here it looks exactly the same, stand in the center, and I guess we're talking about rotational symmetry. Remember दो types की symmetry होती है कि one type of symmetry is कि मैं इसको आधा करूँ, तब भी वो symmetry की है कि it's left side and right side are kind of the same. Rotational symmetry is that you stand in the bottom and you look towards the right, you look towards the left. So kind of looks exactly the same. अगर आप 180 degree rotate करते हो, it looks exactly the same, right? ये वाला symmetric नहीं है, ठीक है? Although this is बीच में से divide कर रहा है, it is symmetric, but it doesn't have rotational symmetry. कि अगर मैं इसमें rotate करता हूँ ना, तो I mean one angle is bigger, the other one is smaller in size. तो उसके जो एंगल्स है ना वो बराबर नहीं है, ठीक है? रोटेशनल सिमेट्री में एंगल्स आर काइंड ऑफ द सेम. इधर कार्बन जो है ना, इसमें अगर आप इफ यू रोटेट इट्स एवरीथिंग इज 109.5 डिग्रीज, ऑल्दो इट्स 3 डायमेंशन. इधर अगर आप एंगल्स देखोगे ना तो वो बराबर नहीं होंगे, मतलब फ्लोरीन वाले एंगल्स तो बराबर होंगे, बट अगर ऊपर से जाओगे तो दैट्स गोइंग टू बी अ बिगर एंगल. Between the fluorine atoms the angle would be smaller. एक साइड पे एंगल बड़ा है, दूसरी साइड पे एंगल एक साइड पे एंगल छोटा है, दूसरी साइड पे the angle is bigger in size. So you just have to guess by just looking at the molecule. और कौन सा उसका molecule oxygen with fluorine, is that the sulfur with fluorine तो हो गया. Let's do other shapes. As you remember, इसमें combinations, I mean you can make any combination. There are lots of combinations. Can a square planar shape, if I have CLs everywhere, is the dipole going to get cancelled out? इस केस में अगर y की जगह CL
जी सर.
cancel out हो जाता, ठीक है? What about this shape, ये जो square pyramidal है? If I had CLs everywhere,
नो सर, एक ऊपर की तरफ.
हाँ, क्योंकि ये सारे तो cancel out हो जाते हैं ना axis पे, but the one that's pointing upwards, who's cancelling it out? No one is cancelling it out, ठीक है? So the electrons will kind of be pulled towards the upper side. So यहाँ पे top पे ना there's going to be a slight negative charge, bottom there's going to be a slight positive charge. Because ऊपर वाला component जो ना, that's not getting cancelled out. What other shapes did we have? इसमें बताओ कि if these two are CLs, will there be a dipole?
No sir.
You will cancel out. What about this one? If these are all CLs, will there be a dipole?
इसमें लोन पे जी सर, इसमें होगा डाइपोल.
क्योंकि ये ऊपर one would be trying to pull the electrons upwards, the other one will be trying to pull the electrons downward. They'll get cancelled out. Their forces of attraction will cancel each other out. Right wala component जो होगा, that's not going to get cancelled out. One CL will be over here trying to pull electrons towards the right. ठीक है? CL को मैं वैसे as an example use कर रहा हूँ because it's electronegative. So electrons जो होंगे ना वो इस side पे चले जाएंगे क्योंकि there's no one pulling the electron from the left side. What about this one? Is this going to have a dipole? If all of them are CLs, I mean, बीच वाला कोई भी atom है, the rest are CLs.
सर इसके पास नहीं होंगे डाइपोल्स.
ये देखो left और right वाला तो cancel out हो जाएंगे, right? One CL trying to pull electrons towards the left, the other one trying to pull the electrons towards the right. अच्छा, ये दो CLs क्या कर रहे हैं? They're both pulling the electrons downwards, right? उधर खींच रहे नीचे की तरफ, इधर खींच रहे नीचे की तरफ, तो कोई ऊपर की तरफ खींच नहीं रहा. तो ये दो CLs क्या करेंगे? They'll create a dipole. They'll pull the electrons downwards. Is that clear?
जी सर।
इन दोनों का ना इफेक्ट कैंसिल आउट नहीं होगा। तो मतलब प्रैक्टिस से ही आइडिया हो जाएगा कि गेट एन आइडिया कि इधर क्या होगा, डायपोल कैंसिल आउट और नॉट कैंसिलिंग आउट।
जी सर, इधर हो जाएगा कैंसिल आउट।
नहीं होगा वो, एक ये दोनों वी
ओ
शेप।
सॉरी सर, हाँ वो दो लोन पेयर थे।
हाँ लेकिन
ओके।
वी शेप्ड है ना, तो वो एक इधर खींच रहा है, दूसरा भी इधर ही खींच रहा है, तो वो ऑक्सीजन के इलेक्ट्रॉन जो है वो इस साइड पे आ जाए। मतलब वो खुद ही सोचो, दो बंदे एक चीज को खींच रहे हैं, यहाँ पे बीच में there's a chair, one is pulling over here, the other one is pulling over here, so they're not cancelling each other's force, they're वो बल्कि दोनों ही उसको इस साइड पे खींच रहे हैं, ठीक है। इधर भी वही होगा, dipoles are not going to get cancelled out तेरे middle में। All three CLs are basically pulling the electrons in a downward direction. Laterally या horizontally they might cancel each other out, they would cancel each other out, लेकिन net effect होगा कि तीनों नीचे की तरफ खींच रहे हैं। यहाँ पे obviously cancel out होगा कि for our CLs they will cancel out, dipoles will cancel out, इसमें it's all going to get cancelled out, इसमें it's going to get cancelled out perfectly, ठीक है। तो idea clear है कि when it's going to get cancelled out, so you have to have an idea of every shape, ठीक है। Is this clear?
ओके सर। जी सर।
बाकी clear है Abdullah? Zabiba, is this clear? Ahmed? So clear है? अच्छा, इसमें अब दूसरी जो चीज है that is कि we had all of them as CLs or we had all of them as oxygens, right? A molecule is kind of more complicated. Even if it's linear, it still can have dipoles because not all of them are going to be CLs, ठीक है? तो एक तो shape of molecule plus atoms पे भी depend कर रहा है ना. So a linear does not mean that the dipole would always cancel out. ठीक है? You have to keep an eye out for the electronegativity of the atoms. ठीक है? So for example, I've got HCN. अच्छा, HCN जो होगा that's this thing. तो मसला ये है कि even though it's a symmetrical shape, it's linear. अच्छा, even though it is linear, लेकिन N जो है ना that's way more electronegative compared to the other ones. C और H के मुकाबले में ना N is way more electronegative. So तो यहाँ पे ना जो उसका dipole होगा ना that's belonging to N, that would be kind of bigger and stronger. N will have a lot stronger attraction. H का dipole बहुत ही weak होगा. H is hardly attracting electrons. So the net effect will be that this side will become negative, side negative, this side will become side. Remember the dipole appears at the ends. मतलब जो electron cloud होगा ना overall molecule पर, it's going to get shifted towards the right. So this side will become negative and this side. So remember the dipole will only cancel out if it's having equal strength. अगर तो equal strength नहीं है, ये carbon है बीच में और दो बंदे उसे खींच रहे हैं, one is pulling its electrons to the right, the other one is pulling to the left. Right वाला अगर stronger है तो obviously the electrons will all be pulled towards the right. ठीक है? Clear है?
जी सर।
अच्छा, same goes for the other molecules as well, like अगर मेरे पास होता, if I had fan shape पे, if I had a carbon and I had a double bond oxygen next to it, and on two sides I had, अच्छा दो साइडों पे ना I had hydrogens. So if you have a look at this molecule, So if you have a look at this molecule, then again it's fan shaped, so it is a symmetrical shape. लेकिन वही मसला होगा कि one of the dipoles is going to be way more stronger, ठीक है, specifically ये जो right वाला है, ठीक है, that's ये वाले जो dipoles होंगे ना, they're going to be smaller in size. अच्छा, so these ones काफी छोटे होंगे. It's not very electronegative. और ये वाला जो होगा, that's going to be very powerful, ठीक है. So the net effect, overall effect on this entire thing will be के पास वो ये वाली side that's going to become negative, very strongly negative. This side, this end will become positive, and this end will also become, it's also going to become positive, ठीक है. So remember, there's going to be a dipole-dipole attraction every time. So if you have an HCN molecule, so one HCN molecule will attract another HCN molecule, and उसका जो negative part है ना, that's going to get attracted to. अच्छा, तो उसका जो negative part है, that's going to be attracted to the positive end of the other one. So वो dotted lines है, so they'll ask you to draw these permanent dipole interaction. वही इसमें होगा कि one molecule and there's another molecule, so the negative part of one end will attract the positive part of the other molecule. कुछ molecules में dipoles होंगे, कुछ molecules में dipoles नहीं होंगे. And the dipole strength, the last point है, dipole strength जो है ना, that depends on one is shape, which we have already discussed. क्योंकि shape होगी तो वो cancel out भी हो जाएंगे, ठीक है. And the other one is the difference in electronegativity. So that's pretty obvious that if you have a large difference in electronegativity, just say HCN, so there's going to be there should be a stronger dipole. So that's the second factor. So large difference in electronegativity leads to the creation of a stronger dipole. अगर electronegativity difference होगा ही नहीं, तो it's going to be a very weak dipole. For example, if I have fluorine bonded to Cl and I've got fluorine bonded to bromine, so here the dipole, I mean, chlorine is kind of strong, but fluorine has a slightly stronger attraction. So dipole banega, this side will be negative, this side will be positive, but it won't be that strong. This one is still fluorine, so it has the same force. But bromine being less electronegative, way more less electronegative, ठीक है, उसकी इतनी strength नहीं होगी. So यहाँ पे the dipole will be stronger. The fluorine will have a more negative charge, and the HBr will have a stronger positive charge. So that would lead to stronger dipole. ठीक है, तो electronegativity difference जितना ज़्यादा होगा, उतना strength of dipole that's going to be greater as well. ठीक है, तो उतनी dipole की जो strength होगी वो ज़्यादा होगी. Is this clear, this idea?
जी सर.
So this one is a weaker dipole, the other one is अच्छा, the other one is a stronger dipole. चलो ठीक है, ये फिर कंटिन्यू करेंगे. हमने dipole attraction तो कर लिए, ठीक है. Just remember कि you would just have to guess about the symmetry of the molecule and see कि if it's symmetric, then it will cancel out. If it's not symmetric, it's not going to get cancelled out, ठीक है. Secondly, it's not just symmetry, it's even if the molecule is symmetric, वो एटम्स एक जैसे हो, अगर एक जैसे नहीं है, उनकी इलेक्ट्रोनेगेटिविटी डिफरेंस इज नॉट एग्जैक्टली द सेम, देन द इलेक्ट्रॉन्स विल ऑब्वियसली गो टू वन साइड compared to the other side, and that side will become negative, the other side will become positively charged. So ठीक है, यहाँ से कल कंटिन्यू करते हैं, ठीक है, we'll do the other attractive forces as well. ये पहली तो वो होगी, ठीक है।
ओके सर। सर ये रिकॉर्डिंग भेज सकते हैं?
हाँ मैं भेज दूंगा, मैं कल तक भेजूंगा, ठीक है।
ओके सर।
ओके, हाफिज।
अल्लाह हाफिज।